In this presentation, I'll try to I'll try to show some of the causes and consequences. The consequences are the outputs or the results of what we see in terms of bird endemism in Ethiopia. Actually, my first title was Bird Diversity in Ethiopia, but I thought that that would be very wide in its application. So I didn't think it would make sense to make a presentation on in such a kind of scenario where I would be talking about bird endemism in terms of colonization of the land. So I am assuming to be an evolutionary biologist, but with the kind of it's one of my interest areas to know the origin of Ethiopian birds, and so I'll try to show what I'll try to show what the effect of geologic history has had on Ethiopia's birds, especially with the endemics. Now, my outline would be to try to give you Ethiopia's location and geography in the beginning as an introduction. So the meat of the presentation will be on geologic history and colonization, and actually what it means to present day conservation of Ethiopia's endemic birds, which are unique to the land. So as a background, Ethiopia is found in northern Eastern Africa, what is commonly known as the Horn of Africa, and covers an area of approximately 1.2 million square kilometers. It's a landlocked country, sharing boundaries with Eritrea, Djibouti, Somalia, Kenya, South Sudan, and Sudan. As a background, and which may be important to this presentation, is that it is highly populated, and at the moment it is known to be the second most populated country on the continent. So it has an agrarian economy where not less than 80% of its population is engaged in agriculture, and there is also a semi-nomadic livelihood, which mainly whose livelihood is mainly rearing livestock. But nowadays we see that there are people who also do some amount of agriculture in connection with rearing livestock. And it may arguably have the highest livestock numbers per unit area at the moment. The mountainous landscape is characteristic with rich diversity of climate, biodiversity, ethnicity, and culture. Ethiopia is also distinguished from other countries with the extent of high ground that it has. At least 15% of Ethiopia lies above 2,000 meters, and 2% of this area, or the land mass, is above 3,000 meters. Taking the whole Afrotropics, there are different landscapes and different terrain, but of that, of the land is above 2,000 meters is found in Ethiopia, and nearly 80%, actually it's 79.4 something, but just as an estimate, nearly 80% of land above 3,000 is found in Ethiopia. So these altitudinal variation and associated climate factors determine the distribution of not only fauna and flora, but also activities of human beings, so livelihoods. So agriculture and any kind of engagement with the land is, as we've mentioned, 80% of the people are agrarian or farmers. And so any or almost all activities are associated with the climatic factors in the country. The high mountains in the country also form headwaters for a number of huge water sources like the Nile, Wabi Shabele, Ganale, and Juba, which all drain into neighboring countries, and like Nile being the longest river in the world. So we can see that they're very it's very important as a water catchment and as a water tower. In Ethiopia, we know that at the moment, I mean, you can use different taxonomic approaches, but sort of the recent one which has been developed by IOC, this is version 11.4 or something, the most recent one. Ethiopia has 870 species of birds. This, in some instances, can go all the way to 900 species because it's just about lumping and splitting different species. So if a subspecies becomes a full species, then of course the numbers will be less. But if you consider subspecies almost as important as the species themselves, then this can go way up. But at the moment, what is understood can be is not more than 870 at the moment. So on the continent, it is one of 10 countries with high bird species richness. It's also known that out of those 870 species, at least 135 species have 75% of their population, totally 75% of their population in Ethiopia. So it means at least one taxon could be species or subspecies level, nearly restricted to Ethiopia. But the other important thing is that as knowledge grows, we see that the endemics in Ethiopia, confined to Ethiopia, are on the rise. We know that there had been something like 29 endemics with about at least 12 or 13 shared with Eritrea, and another 16 being totally found or restricted within Ethiopia. But this may rise in the coming years or decades because a number of species are considered to be good candidates for species level. So at the moment, this can go all the way up to 50 species, perhaps. So these taxa will mostly need further investigation, but there is a likelihood that that most of the species can be raised to an endemic level. Continuing with bird diversity, avifauna, as you know, is birds in a certain geographical area. And the avifauna of Ethiopia, with its diversity and endemicity, has a history behind it, because everything in the making of an avifauna of a territory or a region hasn't come around just by sort of pure chance. There had been historical evidence of birds colonizing an area, just like plants or even fish or frogs would do it. But I think maybe birds are more prone to colonizing an area more quickly, swifter than any other species, because of their ability to fly and to fly out, as long as there are no major barriers. And if there are corridors of forest or likely good or favorable habitat, they will be able to colonize an area much faster. But what we see today in terms of high mountains, sort of the extensive tropical plateau and the grasslands, deep ravines and valleys are a testimony of geological habitats or geologic upheavals in the past. So the landscape of Ethiopia, as any other, has a history behind it. And this cannot be, I mean, Ethiopia can be said to be a living museum of changes in the past, where we've been able to see these upheavals uh, even in the near past. I mean, geologically near past, it could be like 20, 30,000 years ago or 50,000 years ago. And these upheavals have made quite quite a mark on the landscape as we see it today. One evolutionary biologist whom I highly respect is Jonathan Kingdon, and he's been to Ethiopia several times. And the last time I saw him was maybe back in the, I think maybe about 30 years ago, or nearly 30 years ago in Bale Mountains. And he had different hypothesis uh, of how fauna, especially mammals and birds, colonize an area. And in his book Island Africa, which I believe most of you know, he he outlines different sort of ideas of what he has been thinking about evolutionary biology of the African landscape. And when it comes to Ethiopia, he mentions it as the fractured dome. And I shall be looking into that in a little while. But from his suggestions, one thing, there are about sort of 4 ways in which Ethiopia's high ground landscape became colonized by different forms of life. And the first one, and sort of the straightforward and obvious one, is immigration from surrounding lowlands. This would have been the most apparent. It was an avenue for recruitment into new area, because I mean, all those lowland areas which had the chance would come into sort of open areas. And the second one were colonizers from African moist tropics, most probably the South and the Southwest. So this would include anything from Congo, Rwanda, Uganda, parts of Kenya. But then, of course, their mode of locomotion, their mode of colonizing wouldn't have been very quick, because of the, I mean, these highlands were practically islands by themselves, surrounded by a sea of deserts. And this would have been a big impediment to these species being able to colonize the highlands much faster. And then, of course, there are immigrants from Eurasia, from Europe and Asia, in what's now through what's now regarded as the Arabian Peninsula, mostly through Bab el Mandeb. So they would use the Afar Triangle, and they would come through that funnel of land, which connects the rest of the world to Ethiopia and the rest of Africa through this way. And then, of course, there would be those vagrants, which once in a while would come through, maybe on migration, but from their own cold domains, they would come to the Ethiopian highlands, and they would find habitats that resembled their own. And so I think if they find that it is suitable, they would be in a state of sort of settling down and trying to see what they can do with it. But once they are in, and maybe if they're able to breed and to bring up offspring, they would find that maybe a separated population would remain in Ethiopia. One such species, which I'll look into later, is the red-billed chough, which is quite common in other parts of the world. And in Africa, we find that it's only in sub-Saharan Africa, we find that the red-billed chough is only found in Ethiopia and nowhere else. And so I think this is like the one kind of species that has come in and settled and found a home in the highlands. So, I mean, so as I mentioned, avifauna is defined birds in a geographical area, but even the endemic species would have that kind of history behind them. And I'm trying to show that the geological history of what happened in Ethiopia and its ability to be isolated, and then of course the success that came with colonizing those maybe cold and dry highland areas which suited the endemics, was like the ingredient needed for them to survive and also to reproduce and become a different kind of species. So I think that's where I'll be concentrating. And extensive African plateaus and grassland deep ravines are a testimony to geological upheavals. And Ethiopia has that big sort of huge difference in terms of altitude. So if you go to the northern parts of the country, where some mountains are above 4,600 meters, and to the northeast, if you go to the Dalol in the Afar, there are sites which are less than 125 meters below sea level. These are a testament to the kind of altitudinal scale that we're talking about. Between these, you have lots of things to play around with. So climate, the altitude then, of course, would determine the vegetation. And along with it, of course, is the climatic factor, which will be the most important ingredient to determine where a species is likely to occur or not occur. So when we look at the geologic history and background, we all know that as biologists, ecologists, zoologists, whatever, ornithologists, geological accounts and climate are taken as proximate and even justifiable causes for biological diversity. It's one factor. And that's very, very important, because when you determine biogeography, that is very important. And so I'm taking it into account this factor and putting it into the endemic lives of our birds here in Ethiopia. The Ethiopian highlands are estimated to have started forming maybe like 75 million years ago. And it's known that kind of a dome, actually a huge dome came it was created, and it was mostly because of volcanic activity happening below. And so what drove this dome to rise above all the land around it was the volcanic activity that was spewing lots of lava during the time. So the high plateau of Ethiopia is the result of intrusion of lava in the tertiary period, as we as we understand from geologists. And this was deposited in a form of a thick basalt. And then some 35 to 45 million years ago, this outflow of lava was astonishingly high in some areas. When, like, if you go to the Cement Mountains, it was as high as 3,000 meters above sea level. And after this, what happened was the high plateau was created after the Oligocene lava flows. It's rearranged themselves into an arc. And this was again overlain by during the Oligocene and the Miocene with lava flows. Then in the early Miocene, rifts began to open on the Ethiopian plateau, splitting the western and southeastern sections. And actually, this was fully formed in the early Pliocene, which was some 5 to 4 million years ago, as estimated by geologists. So the volcanic eruptions in the Ethiopian highlands, like from 45 to 5 million years ago, made it very, very difficult for plants and animals to find and establish a stable ecosystem. So even like 5 million years ago, it was not really evident to see there were plants or animals there, because it was still undergoing a lot of intrusion and a lot of breaking up of the crusts and a lot of upheaval. So according to geologists, we understand that these highlands became inhabitable only in the last 4.5 to 4 million years ago. But even then, soon after these intense volcanic periods, there were climatic vacillations and fluctuations in the Pliocene and the Pleistocene. I think these were termed like the Ice Age in the northern latitudes, but in Africa, in the tropics, they were known as the pluvials. So, but what happened was that there was not only rain, but there was also ice and I mean a cover of glaciers in the highlands of Ethiopia during that time. So these climatic fluctuations during the Pliocene were actually not all wet. There were periods which were dry and cold. And specifically, and this impacted the highlands through glaciation. This up to maybe, this happened during the last 120,000 to 20 years ago. But even like, when I say 20,000 years ago, in the Bale Mountains, there is evidence that the mountains of Sanate, like the Tuludimtu, were under glacier even like 14,000 years ago. So even as close as that. So during the last ice age, Bale Mountains were one of the most extensively glaciated areas in Ethiopia, with a total ice cover of approximately 180 kilometers square, 100 square kilometers. Tuludimtu, as we know it now, which is the highest peak in southern Ethiopia and the fifth highest in the country, found in Bale Mountains, had like 30 square kilometers of ice cap surrounding the peak. So it was not only the pluvials, the rain, but ice was also the glaciers were a very important what we see in present day. During the Pleistocene, in the highlands of Ethiopia, when glaciation was at its peak, the surrounding mountain but flat areas were covered with open grassland. So it's interesting to know that it was not all wet or maybe all dry, but there were situations or times when this land was actually covered in grass. So like the meadows and the alpine grasslands that we see today were formed much, much earlier during that time. So even though there were glaciers in the highest peaks, these grasslands formed consecutively. At the same time, dry montane forest dominated the montane forests, and heath was found on the lower sides of the slopes. So even during that time, we see that there is a start of habitat creation, for different species. So I think this presents you with some factual basis that even sort of maybe not at the peak of the glaciation period, but soon after that, there were times when all these mountain forests and heath found themselves established. And this in the process actually was much habitable for species who'd come to colonize these favorable areas. So evidence also suggests that with the increase of climate warming, belts of vegetation on the upland area shrunk to become confined. So I mean, as I said, there were these climate fluctuations and vacillations, and maybe when we talk about climate warming, it's not what we see like climate change now, but there were climate changes even during that time. So it was not like one kind of stable kind of condition which crossed one era to another, but there were actually times when it was dry and when it was much warmer. So these much warmer times or periods did not allow vegetation to be established or to flourish in the lower areas. So those species which could not stand dry kind of conditions were forced to limit themselves into what is now known as the tree line. So they wouldn't be able to pass the tree line, but they would be able to find themselves a belt or belts of survival, belts of areas on the mountains where they would be able to run their lives. So given this disruptive geologic epochs, and taking into account the relatively young geological age of the highlands, our mountains, the Ethiopian mountains, remain comparatively impoverished in terms of the fauna and flora. So what's the thing is that when you compare the Ethiopian highlands to the arid, hot southeastern or southern lowlands, they're much younger. Of course, when you consider 4.5 or 5 million years, you may think it's a very long time. But even that time, there was a lot of disruption and upheavals, not allowing species to be to survive or to colonize the area, where relatively the arid lowlands had a much stable a stable kind of condition, environmental condition, allowing different forms. So it could be plants, birds, insects, reptiles, and amphibians to live and to speciate more. But I think what happened in the Ethiopian highlands was the upheavals and all the fluctuations consider it to be much younger than the lowlands. So I mean, there is also, but I mean, it's also, especially with birds, I think those times like 4 million years ago, or even 3 million or 2 million years ago, has provided an important time for allopatric speciation, and a few that were successful in colonizing the mountainous scape. So I think even with this time, with this given time, we've had endemic species which have been able to colonize and to speciate, to allow speciation, especially allopatric speciation, which is actually different from other like sympatric speciation. Allopatric speciation would be more aligned to geographical isolation. So these mountains allowed for reproductive isolation of these species from other species they had radiated from. So I think it's important to see that. Now, when we look at colonization of an area is not easy, and especially when it comes to Ethiopia, the mountains have their own part to play. But we see that the Sahelian and Saharan deserts in the northwest and in the south, in the southwest would be the Nile floodplain, especially the Sud, which is a huge area when you consider small species to cross, even if they're flying. Would be a geographical barrier that most would not be able to survive. And then, of course, in the eastern, in the northeast would be the Afar deserts, and in the south and southeastern deserts, we find that the extensive northern Kenyan frontier land and Somalia would be an extreme habitat to cross for most species. So these are the physical barriers. This will be the physical barriers that these species have overcome to colonize the Ethiopian highlands. Now, we know that because in the earlier slide, we saw that, the most apparent and obvious way in which species would colonize an area is from nearby areas. So it would be the lowlands, the nearby lowlands. But then, of course, there are those which come from Eurasia. We see here a man, and of course, the Ethiopian wolf. I've taken this slide from another friend of mine who has worked with Ethiopian wolves for a long time, Dr. Zelalem. And he shared this and said that this is a very important pictogram because it shows that there were times when the Arabian Peninsula and Africa were connected, and so there would have been much. This is how human beings actually colonized the rest of the world as well. Because if we're speaking about Ethiopia being the origin of human beings, they would have had to cross lands and seas to cross into what is now known as Europe or Asia. And this would have been the most probable site. But also, it's not only for men, but also for a number of species. So it's not only for mammals, but also birds, and even other species could have crossed this thing. So this species would have crossed the Ethiopian highlands during the dry glacial periods, and they would have used the Red Sea flanking escarpments, all these escarpments here, to cross into what is now the Ethiopian highlands. So I think this would have been maybe the most apparent and justifiable means of crossing the continents. So, I mean, even though there were barriers to colonization, a species with an affinity, or an ability for high mountain habitats, appeared to have been favored by existing conditions. I believe that was what was available then. It was cold and dry. There may be forests, there may be meadows, but then, of course, all these areas would have been able uh, to contain those species because uh, because it's not actually about the species, it's about the habitat. It's about the habitat being able to accept the colonizer or the invader, in whatever way you look at it. But so unless um, evidently the ingredients are in place at the time, the species would not be able to to set its foot and find food, shelter, protect itself from predators, and be able to continue with life in terms of survivor. So I think all these things are dependent on what kind of conditions these endemics first found in Ethiopia when they came in. Now, when it comes to colonization, especially from Europe, we have a number of different species, but I just wanted to show you some species which have become almost nearly resident in Ethiopia. And one of them is the ruddy shelduck, the Tadorna ferruginea. So, I mean, this is a Palearctic migrant, but it has found, if you go to the Bale Mountains on the Saneti Plateau, it uses the tarns, the small lakes, to survive, to live and to breed. And the origin of this species is the Palearctic. The ruddy shelduck is very common and widespread in almost all parts of Europe and Asia, but you find it in Ethiopia, and the kind of habitat, the kind of conditions that is found has is very comparable to what it has at home. So it's one of the colonizers. The other one is the red-billed chough. The red-billed chough, I think the nearest you find it maybe would be the Atlas Mountains, maybe, I think. But this especially has, this has become, it's not only the, it's not the, this has actually become a subspecies now. And this subspecies is an Ethiopian endemic. It's called the Phyrocorax bailey, and it is found in the Bale Mountains and in the Simen Mountains, where it has found a favorable area to breed and live. So, I mean, these species have come in, they've found a favorable place, and they've added onto the avifauna of the Ethiopian, into the Ethiopian avifauna. But besides coming and residing, the amount of time they have come through and have lived in these mountains have allowed them to become allopatrically different, speciated, so that they can have their own speciation. Now, if this one is a subspecies and it cannot become like it cannot really sort of, there's no gene flow between this species and the European one. And in time, this will be a species by itself. So I think these are the kind of things that will increase the total number of species of an area or a region. Another one is the bearded vulture. The bearded vulture you'd find in different places in Europe, but I think in Ethiopia you find, well, on the continent in Africa, the biggest, the highest, or the highest population is found in Ethiopia, and this is not just because uh, that is common, but it's found the cliffs, the amount of cliffs and the precipices and the amount of area that it has to breed is far superior to any other place on the continent. And I mentioned that Ethiopia has maybe more than 80% of land above 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 3,000 meters above sea level in in its habitat. So, and I think this has become a very important place. Actually, this one is an African species as well now, or subspecies, and it has come again during the glacial dry periods. But I think for a bird like the bearded vulture, it doesn't. I mean, it cannot be stopped by seas and different things because of its ability and affinity to cross large expanses of continents without any problem. So, I mean, besides this, I think maybe when we concentrate on the Afrotropic species coming into Ethiopia, the only chance they would have to come is through these dry areas, through Somalia, through northern Kenya, or the Sud in the southern Sudan. But then, of course, they would have passed through very difficult times, and I'm sure that when they've made it, and if they've made it, they have made a huge sacrifice, because crossing these areas without any other corridor is a pure spirit of determination on the part of the birds. Now, this is the thick-billed raven, which looks very like the white-necked raven you find in other Eastern African countries. But I mean, birds like this would have arrived at opportune times during through the dry lowlands and the wet southwest, braving their way through deserts and swamps. So I think there is a bit of determination there. Now, other endemics which now are adapted to living in grasslands, forests, or wetlands would have crossed the barrier when the geologic period again was right during alternate wet and dry seasons. Some species like the Prince Ruspoli's turaco, which is found only in few places in the southeastern highlands, southeastern forests in Ethiopia, is totally confined to these areas. Even within Ethiopia, it's so localized that any loss of forest would hugely affect it. Other ones like the banded barbet, which is found both in Ethiopia and even in Eritrea, is much more widely distributed, but it has several subspecies. So there is, again, this is one species where some of its subspecies could be endemic and could be raised to another endemic entity, an endemic which has other endemic subspecies. This one is the used to be called the golden-backed woodpecker. Now it's known as the Abyssinian woodpecker. Very small indeed, and doesn't really look like a woodpecker, especially with a very small bill. But it looks very much like the cardinal woodpecker, and would maybe have some kind of a connection to that. I mean, and all these things can be found out through the DNA molecular studies. But some of these species really are alike or have affinity with other species in the lowlands. Another species which is found in a very wide area and in highland swamps and even in towns like Addis Ababa, using uh, uh, using different kinds of urban wetlands, which mostly are polluted, is one sort of unique species that is found in Ethiopia, and it can even cross into Eritrea. That's what I understand. But these are some of the species which have come through. Now, here I'm just trying to show that there are some species similarities with what we find in Kenya. Now, this is the Abyssinian longclaw, which looks very much like the yellow-throated longclaw in highlands of Kenya. This is the thick-billed raven in Ethiopia, and could have been, I mean, this could be, the thick-billed raven could be an outshoot of the white-necked raven, or the Abyssinian longclaw, which is totally confined with Ethiopia in the grasslands, could be again an offshoot of this one. But that some species, some endemics provide evidence, morphological evidence that share family traits with other distant species. But again, this is more of a if not primitive, it's a very traditional way of looking at things, looking at different birds and trying to look for similarities in terms of morphology. But I think with advances in molecular and DNA work nowadays, we are, or will be more sure of what species is more related to another in terms of family lineage. And the same one here. This I took this picture from Henu, and this one is the olive thrush. We used to consider the Ethiopian or the Abyssinian thrush as an olive thrush some years back, maybe like 15 or 20 years ago. But there was evidence, and a lot of evidence, that the Abyssinian, I mean, by the way, this is not an endemic species, but we find that there is a lot of similarity and sharing with the olive thrush, which is found in Kenya and south of Kenya as well. I think this was taken in South Africa. This is the African thrush, but we can see that they all share some similarities. But then, of course, I could have added the bare-eyed thrush, the Kurichani thrush, and they would all have some kind of similarity. But then, of course, with the thrushes, you can see that they share a lot of characteristic, and one being very similar to the other. So even at the first glance, you would not miss the situation and saying that this is a thrush, but you'd have to go deeper than that to see how one species would be different from the other. So there is clearly an evidence that lots of our species, or a number of our species, share traits with other species in nearby regions or countries. Now, when it comes to colonization, again, there are sort of great barriers like deserts and can be deterrent for species. But it's not only about the barriers I see, because there are the sort of inherent attributes of specialization of a species that does not allow that species to move to a newer location. So even if there are barriers, a species would have some kind of a specialization within it that will not allow it to move out from its area. I mean, saying that, I brought this again to show you that that there is maybe maybe one or two species which I'm always sort of amazed at and really don't understand. One is the blue-winged goose, which is totally endemic to Ethiopia now. There are no offshoots in Eritrea. This goose has a relative, the closest relative of this shell duck, it's actually a shell duck, is found in the Andes, South America. Can you believe that? And I mean, if this holds true, then it would mean that this bird was around for more than the last 4.5 to 5 million years ago. So even before the mountains of Ethiopia started to become colonized by other plants and animals. So, I mean, if you know the creation of the Gondwana land, that's when all the continents at creation were all together. And before they separated. What I was saying is that how did it survive the geologic upheavals in the Oligocene and the climatic fluctuations of the Pliocene? And if not, how did it manage to cross over so many national barriers or natural barriers to come to Ethiopia? So I mean, these are some kind of anomalies that we see. So, and at another level, in the south and southwestern forests of Ethiopia, we don't have the complementary forest species of like Kenya, Uganda. We don't have green bulls, Elidopsises, accolades, alethes, all the robin chats and bristlebills. And so while the habitat was available for the colonizers, these forest dwellers did not have the specialization to invade new spots because they would be at risk from coping with critical physical and environmental factors coming through to Ethiopia because of all the deserts. There were no corridors. At the moment, Ethiopia has a big sort of burgeoning population. That means it needs, all these young people need food, there's settlement, and there is also development and infrastructure that's necessary. And for these endemics in Ethiopia, the problem of survival is not only attached to human-driven disturbance, but also for their ability to quickly adapt to changes. And it seems that evident that human population development will go unhindered. What we haven't been able to do is balancing biodiversity conservation with intended development. So it means we'll need some conservation strategies. The evolutionary history of Ethiopia's endemic birds has been shaped by a combination of genetic diversity and isolation and pressing conservation challenge. So it's better to have an understanding of geological drivers in order to effectively produce conservation strategies for these species. So there are a number of things that we can say about the insights from past studies have shown that genetic diversity and geographic isolation is very important. There are conservation challenges to each species. And there are conservation mechanisms that we need to apply. And in this, maybe evolutionary drivers maybe could be more important even than climate change, because I think we need to apply and understand and think about habitat island hypothesis in order to conserve these species. So we have seen resilience in our endemics cutting through ice, desert, and seas. The little we can do is to set the scene so that their legacy of tenacity and tenure continues in the coming millennia. So, and the little we can do is to set the scene so that their legacy and tenacity continues in the coming millennia. So yeah, thank you very much. And this is what I have.
Donc, bonjour à tous. Alors, je vais rapidement résumer la thématique principale de la présentation. Donc, Monsieur Yilma, c'est un ornithologue expérimenté éthiopien qui travaille notamment dans la conservation de la faune d'Éthiopie, ainsi que la gestion des ressources naturelles. Et donc, lui, il s'intéresse beaucoup aux origines de la diversité des oiseaux éthiopiens et notamment les espèces endémiques des zones montagneuses. Comment les espèces ont pu arriver dans ces zones de haute altitude et pourquoi on observe un fort taux d'endémisme dans ces régions. Donc, pour rappeler rapidement, donc l'Éthiopie qui fait partie de la Corne de l'Afrique. Et si mes souvenirs sont bons, donc pour l'Éthiopie, on a deux hotspots de biodiversité. On a celui de la Corne de l'Afrique, mais aussi au niveau des montagnes, justement, c'est le hotspot afrotropique, si je me souviens bien. Et donc en Éthiopie, on a 15% du territoire qui est situé au niveau de 2000 mètres d'altitude et 2% du territoire qui est au-dessus des 3000 mètres d'altitude. Et en fait, le fait d'avoir des chaînes montagneuses aussi élevées, ça va créer un gradient en termes de climat, en termes de précipitation, de température, qui va donc générer différents types d'écosystèmes et donc différentes niches écologiques pour notamment les espèces d'oiseaux. En Éthiopie, on a environ 870 espèces d'oiseaux qui sont recensées et dont 135 espèces ont 75% de leur population en Éthiopie. Et on a 49 espèces qui sont endémiques à l'Éthiopie. Et donc, le travail de Yilma, ça a été justement de s'intéresser à l'origine de cet endémisme et donc de savoir au fil des âges géologiques quels ont été les moments clés qui ont permis la colonisation progressive des zones d'altitude en Éthiopie et aussi pourquoi ensuite on a eu un isolement géographique au niveau de ces régions-là. Et donc, les chaînes montagneuses d'Éthiopie ont une origine volcanique, donc qui se sont formées il y a environ 75 millions d'années. Et donc, au départ, ça formait une espèce de vaste dôme volcanique. Et petit à petit, en fait, ce dôme, donc, ces activités volcaniques ont évolué pour laisser place à une chaîne montagneuse de haute altitude qui a connu notamment des périodes glaciaires. Donc, en fait, les montagnes étaient couvertes de neige. Et donc, ce qui est intéressant, c'est que donc, ces chaînes de montagnes sont assez isolées finalement. Elles font office un petit peu d'îles puisqu'elles sont entourées de zones désertiques. On a par exemple la zone sahélienne à l'est. À l'ouest, on a le désert Afar. Et puis au sud, on a aussi au niveau du nord du Kenya une zone aride. Donc, ces montagnes sont assez isolées. Et donc, concernant les espèces endémiques, on a différentes origines. On a des espèces qui ont des origines afrotropiques, oui, donc qui ont colonisé les montagnes en traversant les zones de basse altitude, en venant des pays, des régions voisines, du Kenya ou de l'Afrique de l'Ouest. Et par contre, on a aussi des espèces qui sont venues, qui ont des origines paléarctiques, donc qui sont venues plutôt d'Eurasie et qui ont pu aussi, pendant des moments propices, arriver jusque dans les montagnes éthiopiennes. Et au fur et à mesure de l'évolution justement du climat et notamment du réchauffement climatique, on a eu finalement une isolation de plus en plus importante de la région montagneuse d'Éthiopie. Et donc, on a eu toutes ces espèces qui ont colonisé cette zone-là ont certainement subi une évolution, une spéciation allopatrique, c'est-à-dire que c'est l'isolement géographique qui va faire que les espèces qui ont colonisé vont petit à petit en fait se différencier des espèces dont elles sont à l'origine. Elles vont créer en fait des nouvelles espèces parce que l'isolement géographique va créer un isolement aussi reproductif et elles vont subir leur propre pression de sélection en lien avec la zone où elles sont. Donc, c'est comme ça qu'on va voir apparaître des espèces qui sont vraiment confinés et spécialisés sur les territoires des hautes montagnes éthiopiennes. Donc voilà pour le résumé. Et donc, en conclusion, il a notamment mis en lumière tous les enjeux futurs concernant ces espèces qui sont maintenant endémiques et confinées dans les montagnes éthiopiennes, puisque l'Éthiopie connaît une croissance importante de la population, de la population humaine, ce qui signifie qu'il y a un besoin en ressources alimentaires, en infrastructures, en zones pour créer des villes et des villages. Et donc, il y aura un enjeu de gestion, à la fois de répondre aux demandes d'une population croissante, tout en essayant de conserver les habitats naturels de ces espèces, puisqu'elles ne peuvent pas vivre ailleurs, elles sont vraiment liées à ces montagnes. Voilà, merci.